Now, after we have learned and we know how to determine the f-test, and we have recognized and know what is the equation involved, now let's take a look the example for one-way ANOVA. Let's take a look. Let's focus to this example. A manager wants to determine whether the mean times required to complete an assignment differ for the 3 levels of employee training. He randomly selects 5 employees with each of 3 levels of training, which is beginner, intermediate, and advanced. And table 1.2 represents time employees take to complete an assignment for the 3 different levels of trainings. And we have 3 different groups, which is beginner, intermediate, advanced. And the entries observation in table 1.2 show the resulting times of employees to complete an assignment for the 3 different levels of training. The manager wants to determine whether the mean times required to complete as assignment differ to the 3 levels of employee training. Test using alpha equal to 0.05. Okay. For this question, first of all, let's discuss why it's considered as a ANOVA. First, we can see that in this example, it consists 3 different levels, which is beginner, intermediate, and advanced. And this indicates that we have 3 different groups of data, which is beginner, intermediate, and advanced. And while we use ANOVA to compare the mean score of these 3 levels, which is beginner, intermediate, and advanced. And since we want to comparing the mean score, that's the reason why we use ANOVA due to we have more than 2 different independent groups. Now let's take a look how we can determine the value of the f-test and how we can determine is there any significant difference between the beginner, intermediate, and advanced. Like we have discussed at the previous slides, we will determine the value of the group and we will determine the MSE on based on the formula given. So, since the manager determine whether the mean times required to complete an assignment differ to the 3 level employee training, and we will use alpha 0.05. So, let's discuss first the hypothesis. So, from this statement, so we can come up with the null hypothesis, which is mu1 equal to mu2 equal to mu3. mu1 equal to the mean time score for the beginner, mu2 for the intermediate, and mu3 is representing the mean score for the advanced, and mean times are equal for all 3 levels of the trainings. And for the null alternative hypothesis, there is no difference between the mean times for the 3 levels of training. So, based on the value given in this example, we can determine the total mean for the beginner, which is 54.9. The mean score for the intermediate is 54.5, and the mean score for the advanced, for the 5 sample in the advanced group, we have 52.5. And altogether, the total number of the mean score is 161.9. And since it's we know that the number of the sample each of the level is 5, so n1 equal to 5, n2 equal to 5, and n3 equal to 5. And therefore, we will have a total number of sample, which is capital of N equal to 15, and K equal to 3, because we have 3 different level of the group. Now, let's recall back what we can what we can determine the hypothesis for this example. So the null hypothesis is equal to mu1 equal to mu2 equal to mu3, which is mean times are equal for 3 level of a training. And alternative hypothesis is mu1 is not equal to mu2 is not equal to mu3, which is not all means times are equal for all three levels of training. And therefore, like I have explained just now, in order to determine the F value, we need to determine the SS street and also SSE. From the SS street and SSE, we will determine the SST. And therefore, so SST is equal to summation of n yij square minus y square over n. Therefore, from all the values that we know, so we can total the summations of the square of the value, which is 10.2 square plus 11.3 square plus until 10.5 square. And we will minus the total of the y, which is 161.9 squares over 15, which is the number of the sample. And therefore, we will get 1752.13 minus 1747.4407. And therefore, we will get the value of SST is equal to 4.689. And to determine the SS street, and we will have the summation of y square over ni minus summation y square over capital of N. And therefore, we will try to square all of the mean score for each of the training level, which is 54.9 square over 5 plus 54.5 square over 5 plus 52.5 square over 5 and minus 161.9 squares over 15. And therefore, we will get 1748.102 minus 1747.4407. And lastly, we will get the SS street equal to 0.661. And from this value, we can determine the SSE, which is SSE equal to 4.689 minus 0.661. And therefore, we will get SSE equal to 4.028. Based from the calculation that we have determined just now, we can translate into a ANOVA table. So what you can observe here, and also as I mentioned and described earlier, so we have 5 columns, and for the treatment between levels, sum of square, you will get 0.661. For the SSE, 4.028, and SST, 4.689. And for the degree of freedom, since we have 3 level of training, so 3 minus 1, which is k minus 1 equal to 2, and n capital minus 3, which is n minus k, 15 minus 3, you will get 12, and therefore 15 minus 1 equal to 14. And for the mean square, so we will have a SS treatment divided by 2, which is 0.331, and SSE 4.028 over 12 divided by degree of freedom, so you will get 0.336. And lastly, we will get the value of the F test is equal to 0.985 based on the division of 0.331 over 0.336. Now, we want to compare how this value either greater or less with the F statistic that we will refer to the statistical table. So if you look, the value of the alpha is 0.05 and the degree of freedom is 2 and also 12. So we can see that I highlighted just now in this one in a red color, the value of the F statistic is 3.885. And therefore, from this value, and we are comparing of the F test with the statistic value, so from the statistic table, from the F distribution at alpha 0.05, the critical point is given by F 0.05 to 12 equal to 3.885. Since the F test that we have calculated is 0.985, which is less than F statistics inside the statistic table, which is 3.885, we did not reject the null hypothesis, and we conclude that if we conclude that the rejection rule is that we will reject the null hypothesis, which is f that is greater than f 0.05 to 12, which is equal to 3.85, and therefore there is no evidence that the mean times required to complete an assignment differ for the three levels of the employer training. Just now, I explained to you the example how we can calculate the ANOVA. Now, from this exercise, please do to determine the ANOVA questions. So for this question, is from time to time, a commercial bank observes various employees for this work productivity. On each routine check, they investigate whether the 4 tellers at a branch of the bank serve on average the same number of customers per hour. The manager observed each of the 4 tellers for a certain number of hours. The following table gives the numbers of the customers served by the 4 tellers during each of the observed hours. Teller A, teller B, teller C, and teller D. For the question, perform the analysis of the variance or ANOVA and test the hypothesis at 1% level of significance that the average numbers of the customers served per hour by each of these 4 tellers is the same. Assume that all the assumptions required to apply one-way ANOVA test hold true. And therefore, this is the exercise I want all of you to do about the ANOVA test. I give you 5 minutes to do the calculation and determine either and test the hypothesis either 1% level of significant test average number customers served per hour by each of these 4 tellers is the same. Best of luck. Here is the quick answer for the following exercise. So I hope you got the same with me for the null hypothesis, mu1 equal to mu b equal to mu c equal to mu d, since we have 4 groups, and the alternative mu1 is not equal to mu b, mu is not equal to mu c, is not equal to mu d. And after we have used all the formula, we will have the f test is equal to 5. Okay, the f test is equal to 9.039, and if we compare in the statistical table, you will get 5.092. Based on the statistical table, by using the alpha equal to 0.01, if we contribute, the critical point is 5.092, and the rejection rule is that we will reject the null hypothesis if the null hypothesis is f test is greater than 5.9092, since the f test is 9.039 and greater compared with the statistical table of the f value, which is 5.092, we will reject the null hypothesis at 1% significant level and conclude that there is very little evidence that the average number of the customers served per hour by each 4 tellers in the same. I hope all of you got the same answer with me. I also have prepared some quiz for you. Let's take a look. So this is the quiz 1. I hope you can do. And this is a quiz 2. Just complete the table based on the information that we have. Alright, thank you. That's all for me for the ANOVA topics. Nice to meet you. Thank you.